The goal of this tutorial is to demonstrate how to create different referencing schemes using the RAVE GUI. We assume that you've downloaded and installed RAVE, and this example will rely just on the included demo data. So first let's start RAVE. Here I'm using RStudio, but you could also double-click the icon that was installed to your desktop during the installation. So here we've launched Chrome, and RAVE defaults to showing you the data selection screen. For creating references, we don't need to change too many options here on this screen. We just want to make sure that the project is demo and subject is demo subject. Once you've confirmed that, we can choose load data. Now we want to make sure that the module is the reference electrodes module. If it's maybe defaulted to Condition Explorer or Group Analysis, just click on Overview and then click Reference Electrodes. It's asking us if we want to load the voltage data, the unepoched voltage data, and we do. Once this is loaded, we're taken to the reference module, and I like to hide the modules pane to give us a little bit more space to work. So the key aspect in generating references for RAVE is to understand the distinction between the reference itself and the electrodes that are being referenced. So for instance, let's go ahead and load up the existing reference that's included with the demo data. So under Create Reference Groups, import from, let's say, the default reference. So this loads up data that's already been referenced, and it allows us to view the electrodes on the embedded 3D viewer. So importantly here, we see both concepts in action. First, the reference group, these are the electrodes being referenced. This is group 1, and they're shown here in blue. And in the right-hand group inspection plot, we can see the actual traces. So in the lower panel, we see what reference is being used on these electrodes. So this is a common average reference. References 13 through 16 and 24, so all of the available electrodes, have been averaged, and in this regime, this reference will be just subtracted from each of these signals. And you can see that result here in the group inspection, or you can click over to individual electrode inspection, and this will load up each individual electrode per block and show you the result of the referencing operation. And especially here, you might want to take a look at the periodograms to see which aspects of the signal are affected most strongly by the reference. So let's now try to create a reference. So we already have a reference from electrodes 13 through 16 and 24. So instead, let's try to create a new reference just through electrodes 13 through 16. So we type that into the electrodes included in the reference signal. We generate that reference. And now, once that reference is created, it's saved in an H5 file on disk. We can create a new reference group. And let's go ahead and just also create a new whole reference file. And we can click back to group inspection. And for this reference group, let's just call it, we'll just call it E13 through 16. And we have to specify a type. Now, there's really only 3 types of references, although we have 4 options here. The first and default is no reference. So this means that the data will be loaded as they were collected. They might have been hardware referenced depending on how the data were collected, but RAVE does no further processing. Alternatively, you can do a common average reference. And what the common average reference does is allows you to specify which generated reference to subtract from each of these included electrodes. The bipolar referencing scheme doesn't require you to specify a particular generated reference. Instead, it goes through the electrodes and references them one to another. So here, if, for example, if we were generating a bipolar reference for electrodes 13 through 16, these again are the electrodes being referenced. This is just the name. So here, electrodes 13 through 16, we've chosen bipolar reference. The embedded 3D viewer shows us which electrodes are selected, just the top 4. And we can open the reference table to see what is currently selected. And so we see here that electrode 13 is referenced to electrode 14. 14 is to 15, 15 is to 16, and 16 is marked with an empty reference. When electrodes are marked with an empty reference, this means that they're not going to be available for analysis. This is sort of the electrode that gets left out. This is in distinction to specifying no reference for an electrode, which means it's still included in the analysis. It just doesn't have a reference. So we can choose confirm here and save group. Whenever you make changes, it's always good to make sure you hit save group. And we can look at these electrodes now. There is no reference column at the bottom because they're being referenced one to another. And electrode 16 here is shown in red because it's not going to be available for analysis. Now we could switch the type of this group to something like white matter reference. White matter reference is actually just a type of common average referencing. At this stage, RAVE doesn't actually have access to information to which electrodes are in white matter or not. So if you wanted to use white matter referencing, you would need to generate a white matter reference using the top panel. So let's just say that we know, for instance, that electrodes 15 and 24 are in white matter. So we would choose generate, and this will create the average of electrodes 15 and 24, which would be our putative white matter average. And now when we go down and look at group 1, we would reference it to reference 15, 24. And we can remove electrode 16 as a bad electrode and choose save group. And now it lets us know that these electrodes are now set to be referenced to the reference called 15, 24. So you can see that white matter referencing in RAVE is really just a type of common average referencing. You have to specify which electrodes are in the white matter. Here we've shown changing a single reference group, but of course you can create multiple reference groups. So for instance, electrodes 13 through 16 might be white matter referenced, but electrode 24 might have a common average reference. So we'll give this a name. We'll call the name again will be electrode 24. The included electrodes will be just electrode 24. When we're viewing the reference groups, we just change to group 2. This updates now just to show the single electrode that's being referenced. And now we change which signals we're referencing to. And so perhaps here we want to reference to all of the electrodes, the average of 13 through 16 and 24. No bad electrodes, we choose save group. And now when we scroll up and we visualize this one group, well, this group just has a single electrode in it, but the reference is the average of all of the electrodes. RAVE supports creating multiple reference groups. You can keep hitting the plus icon here to add multiple reference groups. Perhaps you want to do bipolar referencing along each depth electrode. So you could create many different reference groups to reflect that pattern. Once you're ready to save, you go down to the bottom and choose Preview and Export. So what's important here is to go through and make sure that each electrode is being referenced to the signal that you intended. And recall that this type is really more of a label. White matter referencing versus common average referencing, the arithmetic is the same, but you might just need to double check that this reference 1524 is actually the white matter reference. This table is fully searchable, so if you have many electrodes, you could search, for instance, you could search for 24. Here it's showing, because all of these references contain 24, it's showing all of them. If we search for just E24, then it will just return that E24. So it's searching all fields. So once we're done, we give the reference table a name. It's going to default to default. So this allows you to specify, especially if you're only going to have one reference, then you may as well call it default. But here maybe we'll call it experimental, and the file will be called reference_experimental.csv. And we have two options here to save out our references. The first is export, and what this does is generates a file that tells RAVE how to reference the electrodes, but they're referenced on the fly each time you load the data. Alternatively, you can cache one referenced version of each electrode for the power, phase, and voltage signals. And this allows you to load the data much more quickly. So initially, maybe you would create multiple referencing schemes to see how the choice of reference might impact your analysis. But once you've decided on your final referencing scheme, it's often beneficial to export and cache. This is just a trade-off between speed and disk space. So let's go ahead and choose export and cache. And now RAVE is going through and saving all of the reference versions of every single electrode across all the different data types. And once this is done, we'll get a little pop-up letting us know that the process is done, and that if we want to use these newly created caches, we have to refresh RAVE so that it can access the new data. So we'll give it a second, and depending on how fast your computer is, it will take more or less time. So it says, please reload the subject to take effect. So let's choose OK here. And I'm going to go ahead and just refresh my browser and go back to select data. So refreshing the browser causes you to get a new connection to the RAVE server. And if we now look at the reference table, we have two options. We have the default, which is just the common average reference that comes with RAVE, and we have our experimental reference table. And if we load these data, we can now use this reference scheme either back into the reference module, or we can use the Power Explorer module to look at comparisons between different experimental conditions using our new references. But we'll take a look at Power Explorer in a future tutorial.